Question 1. For each specialized Azure AI service, drag it to the appropriate boxes in the correct match column to match it against its description. Each item may be used once, more than once, or not at all. Flags text or image content that is offensive or risky. Correct match: Azure AI Foundry Content Safety. Train and use custom image classification or object detection models. Correct match: Azure AI Custom Vision. Kura extracts fields from complex documents such as invoices or receipts. Correct match: Azure AI Document Intelligence. Provides multimodal content analysis for forms, documents, images, video, and audio. Correct match: Azure AI Content Understanding. Creates searchable indexes from content using AI skills, often used to ground LLM prompts. Correct match: Azure AI Search. I am now going to explain why each of these matches is correct so that the relationships between the services and the descriptions are clear. First, Azure AI Foundry Content Safety focuses on detecting and flagging harmful or offensive material in both text and images, so it naturally fits the description about risky content. Next, Azure AI Custom Vision is designed for training your own image classification or object detection models, which aligns directly with the second statement about custom models. Then, Azure AI Document Intelligence specializes in reading forms such as invoices and receipts and extracting key fields like totals or dates, so it matches the third description. After that, Azure AI Content Understanding brings together documents, images, video, and audio to provide multimodal analysis, which is exactly what the fourth statement describes. Finally, Azure AI Search builds powerful searchable indexes over your content using AI skills. And those indexes can be used to ground large language model prompts with relevant data, so it correctly matches the last statement. Question 2. Fill in the blanks by selecting the correct options from the drop-down menus. To programmatically access a project from Python, create an AI project client with default Azure credential and pass the project endpoint to the client constructor. Let me now explain why these are the correct choices, so the full workflow makes sense. First, AI Project Client is the specific Python client that represents your Azure AI project, so it is the object you construct whenever you want to talk to that project from code. Next, default Azure credential is the helper that automatically finds a suitable identity, for example, from your developer login or a managed identity in Azure, so you do not need to hardcode secrets. Then, the project endpoint is the unique URL for that project instance, which tells the client exactly which project it should connect to when sending requests. By contrast, Azure OpenAI Service API's endpoint or Azure AI Services API's endpoint are different endpoint types and do not replace the project endpoint for this client, and the Azure AI Projects for .NET or JavaScript options belong to other language software development kits rather than the Python client or credential. Question 3. Fill in the blanks by selecting the correct options from the drop-down menus. Applications built with the SDK can send prompts to a generative AI model and then process responses returned by that model. Now let us go through the explanation so you can see why each option fits perfectly. First, applications need a way to talk to the AI, so they send prompts, meaning the code issues a prompt request through the SDK rather than a human typing into a chat box. Next, that prompt must go somewhere useful, so it is sent to a generative AI model, which is the actual model hosted in the project that creates text, images, or other content from the prompt. Then, once the model replies, the application must process responses, which means it reads the model's output and uses it in code, for example, to display an answer to a user or trigger another action in the app. By contrast, retrieve endpoints, resource connections, datasets, or configure agents describe setup or project assets, not the live runtime flow of sending prompts to a model and handling what comes back, so they do not belong in this operational sentence. Question 4. For each statement below, indicate whether the answer is true or false. Azure AI Foundry guides you to configure a search index that is suitable for use with language models. Answer: true. A text-only index fully captures semantic similarity across paraphrases and different languages. Answer: false. Representing content as vectors enables retrieving relevant context even when sources are text or image captions and in different languages. Answer: true. Hybrid search runs keyword and vector separately and returns two independent lists for the application to combine. Answer: false. Now I'm going to explain why each of these answers is correct, so the ideas about search and embeddings are clear. Firstly, Azure AI Foundry includes a guided experience that helps you set up indexes tuned for language model scenarios, so that statement is true. Secondly, a plain text or lexical index mainly matches exact words. Therefore, it cannot reliably capture paraphrases or cross-language meaning, which makes the second statement false. Moreover, when we convert content into vectors using embeddings, similar meanings end up close together in vector space, so we can retrieve relevant context even from captions or other languages. Hence, the third statement is true. Finally, hybrid search combines keyword and vector relevance into a single ranked list, rather than giving you two separate outputs to merge manually, so the last statement is false. Question 5. For each Azure AI Foundry content safety feature, drag it to its universally true functionality. Each item may be used once, more than once, or not at all. Detects attempts to attack the model via user inputs. Correct match. Prompt shields. Checks whether generated text is grounded in a user's source content. Correct match. Groundedness detection. Identifies known copyrighted material. Correct match. Protected material detection. Lets teams define new categories for emerging patterns. Correct match. Custom categories. Now I'm going to explain why each of these matches is correct, so the different safety tools are easy to remember. Firstly, prompt shields watch incoming prompts for signs of prompt injection or other user input attacks, so they naturally match detecting attempts to attack the model. Secondly, groundedness detection evaluates whether a response stays close to the user's provided sources, which is why it aligns with checking that text is grounded in source content. Thirdly, protected material detection scans for known copyrighted material in the output, so it belongs with identifying copyrighted content. Furthermore, custom categories allow teams to create new detection labels when they notice emerging risk patterns, so they match defining new categories. Finally, GPU autoscaling and A/B experimentation are about infrastructure and product optimization rather than safety analysis, so they are correctly left unused in this content safety question. Question 6. A development team wants to train a custom image classification model, but prefers not to write all the code manually. They need a service that provides a web-based visual interface where they can upload training images, manage jobs, and deploy the model. Which Azure AI service should they use? Select one answer. Option A, Azure AI Vision. Option B, Azure AI Custom Vision. Option C, Azure AI Document Intelligence. Option D, Azure AI Translator. The correct answer is option B, Azure AI Custom Vision. Now let us explain why this choice fits the scenario best. Azure AI Custom Vision is designed exactly for teams who want to build image classifiers through a visual portal, so they can upload images, tag them, run training, and then deploy the model as an endpoint with very little code. In contrast, Azure AI Vision mainly offers ready-made vision capabilities such as image analysis, rather than guiding you through custom training with your own labels. Azure AI Document Intelligence is focused on extracting structured fields from documents like invoices, which does not help with classifying pictures of objects or scenes. Azure AI Translator simply converts text between languages and has nothing to do with training vision models. Therefore, the only service that matches the need for a visual interface to train and deploy a custom image classification model is Azure AI Custom Vision. Question 7. Select all languages for which Azure AI Projects packages are available. Option A, Azure AI Projects for Ruby. Option B, Azure AI Projects for Python. Option C, Azure AI Projects for Microsoft.NET. Option D, Azure AI Projects for JavaScript. The correct answers are Option B, Azure AI Projects for Python, Option C, Azure AI Projects for Microsoft.NET, and Option D, Azure AI Projects for JavaScript. Now I'm going to explain why these three options are selected and Ruby is not included. First, Azure AI Projects for Python is a supported language-specific package, so developers using Python can install an SDK that lets them work with projects directly from their Python codebase. Similarly, Azure AI Projects for Microsoft.NET is provided for teams building applications in C# or other .NET languages, giving them first-class integration with Azure AI Projects. Furthermore, there is also Azure AI Projects for JavaScript, which targets Node.js and browser-based scenarios so JavaScript developers can manage and call their AI projects programmatically. However, Azure AI Projects for Ruby is not listed as an available package in this context, so it cannot be chosen as a correct answer, and that is why only Python, Microsoft.NET, and JavaScript are selected. Question 8. For each statement below, indicate whether the answer is true or false. Prompt flow is accessible in both Azure Machine Learning Studio and the Azure AI Foundry portal. Answer: true. A flow encapsulates the entire journey from input to output for a specific use case. Answer: true. During evaluation and refinement, you should first retest edits on a smaller dataset before moving back to a larger one. Answer: true. When a flow is deployed to an endpoint, calling the endpoint does not run the flow. False. Now I'm going to explain why each of these choices is correct, so the behavior of prompt flow is clear. First, the prompt flow experience is available in both Azure Machine Learning Studio and the Azure AI Foundry portal, so you can design and manage flows from either interface, which makes the first statement true. Secondly, a flow is meant to describe the whole pipeline for a task, from inputs through intermediate steps to the final output. Therefore, it correctly encapsulates the entire journey for a specific use case, making the second statement true. Furthermore, when you are refining a flow, retesting changes on a smaller dataset helps you quickly spot issues before scaling back up. So starting with a small set is indeed recommended. And the third statement is true. Finally, once a flow is deployed, invoking its endpoint actually triggers that flow to execute end-to-end. So the claim that calling the endpoint does not run the flow is incorrect, and that is why the last statement is false. Question 9. Arrange the following steps to implement RAG in a prompt flow. Instruction: drag and drop the items into the correct order, starting with the first step at the top. The first step is to use an initial LLM node to modify the user's query by incorporating relevant chat history. Next, run index lookup to retrieve relevant information from the search index. Then, process retrieved results in a Python node to build a single context string. After that, create prompt variants to explore system messages and prompt structure. Next, send the composed prompt with context to an LLM node to generate the response. Finally, return the LLM node's response as the flow output. Now I'm going to explain why this sequence is correct, so the RAG flow feels intuitive. First, adjusting the user query with recent chat history ensures the question is clear before any retrieval happens. Then, index lookup can search for the most relevant documents based on that refined query, which gives the raw context. Afterwards, the Python node cleans and combines those results into a single well-structured context string, so the model receives focused information. Subsequently, prompt variants let you experiment with different system messages and instructions to improve groundedness and style. Once that is ready, the composed prompt plus context is sent to the LLM, which generates an answer using both the instructions and retrieved knowledge. Finally, the model's response is returned as the flow output, completing the retrieval augmented generation pipeline. Question 10. A team is building a multi-node chat application that combines a language model with Python tools. They have already compared a few base models, and now they must validate that the end-to-end chat experience behaves as expected across nodes. What should they evaluate next? Select one answer. Option A. Evaluate the complete chat flow and, if needed, its individual components. Option B. Recheck only the single language model in isolation. Option C. Skip evaluation until after deployment to maximize real-world feedback. Option D. Measure infrastructure latency and ignore content quality metrics. The correct answer is option A. Evaluate the complete chat flow and, if needed, its individual components. Now let us walk through why this is the best choice. First, once different nodes and tools are wired together, the most important question is whether the full conversation experience still produces the right outputs for users. So an end-to-end evaluation of the whole chat flow is essential. Afterwards, if any issues appear, you can drill down into individual components, such as a tool node or the model call, to see where the problem comes from. By contrast, option B focuses only on the single language model, which ignores orchestration errors, tool calls, and data passing between nodes, so it is not sufficient at this stage. Option C suggests skipping evaluation until after deployment, which would remove the safety net of catching mistakes before users see them. Option D looks only at latency and ignores the quality and correctness of the answers. And a fast but wrong system is still a failure, so it cannot be the right next step. Question 11. Which practices help users interpret and appropriately trust an AI system's outputs? Select two answers. Option A. Hide how the model was trained to prevent user bias. Option B. Disclose the system's purpose and important limitations. Option C. Share information such as confidence scores and key factors influencing predictions. Option D. Discourage diverse participation in testing to avoid conflicting feedback. The correct answers are Option B. Disclose the system's purpose and important limitations, and Option C. Share information such as confidence scores and key factors influencing predictions. Now let us walk through why B and C are the best choices. When you disclose the system's purpose and its important limitations, you help users understand what the AI is designed to do and where it might fail, so they can interpret results with the right expectations, instead of blindly trusting them. In addition, sharing information like confidence scores and key factors that influenced a prediction gives people insight into how strongly the system believes an output and what signals drove that decision, which supports informed, responsible use. By contrast, hiding how the model was trained reduces transparency and makes it harder for users to spot potential bias or misuse, so option A works against appropriate trust. Likewise, discouraging diverse participation in testing, as in option D, removes valuable perspectives that help uncover issues across different groups, so it undermines fairness and reliability rather than improving it. Question 12. You're a developer for a company that offers hotel bookings through a chatbot. The marketing team insists the chatbot's responses must use a friendly tone aligned with brand guidelines. The technical team notes that prompts alone haven't consistently produced the desired tone. What approach should you choose to ensure consistent output style and tone? Select one answer. Option A. Continue refining the prompts with more examples. Option B. Fine-tune a base model with examples of the desired style and tone. Option C. Add a RAG component to pull data from the booking database. Option D. Use zero-shot prompting to reduce training complexity. The correct answer is option B. Fine-tune a base model with examples of the desired style and tone. Let us now unpack why this option is the most effective choice for the scenario. First, fine-tuning a base model on many examples written in the brand's friendly voice actually teaches the model that this tone is the default way to respond, so the behavior becomes consistent across many different booking conversations. Moreover, the model internalizes not just wording, but also patterns like how to greet guests, how to apologize, and how to close messages politely, which simple prompt tweaks often fail to enforce reliably. In contrast, continuing to refine prompts with more examples still relies on few-shot prompting, which can help occasionally, but does not guarantee that every reply will follow the brand tone. Additionally, adding a RAG component mainly improves factual accuracy by pulling live data from the booking database, and does little to shape conversational style. Finally, zero-shot prompting reduces the amount of example text, but gives the model even less guidance about tone, so it would likely make the inconsistency worse rather than better. Therefore, fine-tuning the base model with curated examples of the desired style is the best way to ensure the chatbot's responses always sound on brand. Question 13. Which two statements are true about constructing a fine-tuning dataset for chat completion? Select two answers. Option A, role labels must indicate system, user, and assistant within each example. Option B, JSON-L means a single JSON document containing an array of all conversations. Option C, you can include multiple turns of a conversation on one line. Option D, weighting an assistant message with 0 increases its influence on training. The correct answers are option A, role labels must indicate system, user, and assistant within each example, and option C, you can include multiple turns of a conversation on one line. Now let us explain why these two are correct, so the fine-tuning format is clear. In option A, including explicit role labels for system, user, and assistant inside every example tells the model who is speaking at each turn, which is crucial for controlling behavior and maintaining a structured conversation during training and later during inference. Option C is also true because a single JSON object on one line in a JSON-L file can hold a full multi-turn conversation, with several messages grouped together in the messages array, so the model learns context across turns instead of just single question-answer pairs. Option B is incorrect since JSON-L stands for JSON lines, where each line is its own standalone JSON object rather than one big array of all conversations. Option D is also incorrect because giving a weight of 0 actually removes that assistant message from contributing to training instead of increasing its impact, so it has no influence at all on how the model learns. Question 14. For each benefit of using custom tools, drag it to the appropriate boxes in the correct match column to pair it with its description in the option column. Each item may be used once, more than once, or not at all. Automate repetitive tasks and streamline workflows. Correct match, enhanced productivity. Provide precise and consistent outputs, reducing errors. Correct match, improved accuracy. Address specific business needs with targeted functionality. Correct match, tailored solutions. Make custom functionality available for the agent to use. Correct match, tool availability for agent decisions. Now let us go through why each description matches its benefit so the pattern is easy to remember. When we automate repetitive tasks and smooth out workflows, the main effect is enhanced productivity because people spend less time on manual steps and can handle more work in the same time. When a tool is designed to give the same result every time with fewer mistakes, that clearly leads to improved accuracy as it reduces human error and variability. Next, when custom tools are built to solve particular business problems, such as a domain-specific calculator or validator, they are delivering tailored solutions that fit those exact needs rather than generic functionality. Finally, when these tools are wired into the agent so it can call them during a conversation, that gives tool availability for agent decisions, because the agent can decide when to invoke each tool to best serve the user's request. Scalable pricing tier and built-in human approval are not described here as inherent benefits of custom tools, so they remain unused. Question 15. For each statement below, indicate whether the answer is true or false. Custom tools allow interoperability with infrastructure and web services at scale. Answer: true. Function calling is limited only to static functions and cannot adapt dynamically. Answer: false. Azure functions can be integrated with external systems using bindings. Answer: true. Open API specification tools cannot help people understand how an API works. Answer: false. Now I'm going to explain why each of these answers is correct, so the concepts fit together clearly. Firstly, custom tools are designed to connect agents with infrastructure and web services, so they let your AI solution call many different systems reliably at scale, which makes the first statement true. Secondly, function calling is actually built to discover and route to functions dynamically from their definitions, so saying it is limited only to static functions is false. Next, Azure functions support bindings that plug into queues, databases, and external APIs, so they naturally integrate with other systems, making the third statement true. Finally, OpenAPI specifications document endpoints, parameters, and responses in a standard format, which helps people understand, test, and even auto-generate clients for an API. So the claim that these tools cannot help people understand how an API works is false. Question 16. Fill in the blanks by selecting the correct options from the drop-down menus. A ticket triage assistant can streamline operations by using subagents that classify ticket type, set priority, and suggest the right team. Now let us explain how each of these subagents helps the workflow. Firstly, classify ticket type is important because a specialized agent can quickly decide whether an item is a bug, a feature request, or an infrastructure issue, which organizes the queue from the start. Secondly, set priority allows another focused agent to assign urgency levels, so critical outages are handled before low-impact requests, improving response times. Finally, suggest the right team lets a routing-oriented agent recommend which group, such as support, networking, or development, should handle the ticket, so work goes directly to the people best equipped to solve it. Together, these three actions streamline ticket handling much more than unrelated capabilities like video summarization or media transcoding ever could. Question 17. Fill in the blanks by selecting the correct options from the drop-down menus. The Microsoft Agent Framework allows agents to work autonomously while collaborating with other agents through shared orchestration patterns. The correct options are autonomously and collaborating. Firstly, autonomously is appropriate because the framework is designed so agents can make decisions and execute tasks without constant human supervision, which is exactly what autonomous behavior describes. Secondly, collaborating fits because these agents are meant to work together towards shared goals, coordinating through orchestration patterns rather than acting in isolation. By contrast, independently would suggest no cooperation at all, sequentially would limit agents to strict linear workflows, manually would imply human-driven actions instead of agent control, and concurrently would only emphasize running in parallel without the coordinated collaboration that the framework actually provides. Question 18. For each statement below, indicate whether it is true or false. A central chat manager controls the conversation and selects which agent speaks next. Answer: true, true. Group chat orchestration is best suited for hierarchical workflows with no discussion. Answer: false. Human input can be requested in real time during a group chat. Answer: true. All outputs are stored in a single conversation thread for review. Answer: true. Now let us walk through why these answers make sense in a group chat orchestration scenario. First, a central chat manager really does control the flow, choosing which agent should respond next and coordinating turn-taking, so that statement is true. Secondly, group chat is designed for agents to discuss and collaborate, not for rigid top-down hierarchies with no discussion, so the claim that it is best for hierarchical workflows is false. Third, the orchestrator can pause the agent conversation to ask a human for clarification or approval, then resume the flow, which is why real-time human input during the group chat is indeed possible, and makes that statement true. Finally, because all of these interactions are logged into a single conversation thread, every message from agents and humans is available in one auditable place. So the last statement is also true. Question 19. An employee submits an expense claim for a high-value purchase. The system must ensure that the claim is approved by the appropriate manager before processing. Which capability of an expenses agent handles this requirement? Select one answer. Option A, using a chatbot interface for simple Q&A. Option B, automatic claim routing based on claim amounts. Option C, manual human review of all claims. Option D, relying only on recurring claim automation. The correct answer is option B, automatic claim routing based on claim amounts. Now I'm going to explain why option B is the best choice for this scenario. Firstly, the requirement is that high-value purchases must be approved by the right manager, which means the system needs logic that looks at the amount and then routes the claim to the correct approver automatically, exactly what automatic claim routing based on claim amounts provides. Secondly, using a chatbot interface for simple questions and answers only helps employees ask about policy and does not ensure that any specific manager must approve a transaction. Moreover, relying on manual human review of all claims would satisfy the control, but would remove the efficiency benefits of an automated expenses agent, creating unnecessary workload for finance teams. Finally, recurring claim automation generally focuses on repeated predictable expenses, so it would not reliably handle unique high-value purchases that need extra approval. Therefore, it cannot meet the requirement in the question. Question 20. A manufacturing company wants to ensure stock levels never run out unexpectedly. They decide to connect their AI agent with the inventory management system so it can check stock, forecast restocking needs, and automatically place orders with suppliers. What outcome should the company expect from this integration? Select one answer. Option A, streamlined inventory management and optimized supply chain operations. Option B, manual verification required for every order placed by the system. Option C, higher risk of overstock due to the agent ignoring historical data. Option D, reduced efficiency because the agent cannot automate supplier interactions. The correct answer is option A, streamlined inventory management and optimized supply chain operations. Let us now unpack why option A is the best fit for this scenario. By connecting the AI agent directly to the inventory system, the agent can continuously monitor stock levels, use historical data to forecast demand, and trigger purchase orders before items run out, which naturally streamlines inventory management and improves overall supply chain performance. In contrast, option B suggests manual verification for every order, but the whole point of this integration is to automate ordering rather than add extra manual steps. Option C talks about a higher risk of overstock because the agent ignores historical data. Yet in reality, the forecasting logic specifically relies on past sales and usage patterns to place smarter orders, reducing rather than increasing that risk. Option D claims reduced efficiency because the agent cannot automate supplier interactions. But the description clearly says the agent can automatically place orders with suppliers, so efficiency should improve, not decline. Therefore, the expected outcome is streamlined inventory management and optimized supply chain operations. Question 21. For each statement below, indicate whether the answer is true or false. The main agent is responsible for forwarding relevant instructions and context to subagents. Answer: true. Connected agents should be designed with multiple overlapping responsibilities for flexibility. Answer: false. Only the main agent's compiled response is visible to the end user. Answer: true. Subagents decide which agent should execute a user request. Answer: false. Now let us walk through why each of these answers is correct, so the main and subagent roles are clear. First, the main agent really is responsible for forwarding instructions and context to subagents, because it orchestrates the workflow and gives each specialist agent the information it needs to perform its task. So that statement is true. However, connected agents should not be designed with overlapping responsibilities. Instead, each subagent should have a single, clear responsibility so the system stays maintainable and reusable, which makes the second statement false. Furthermore, end users typically see only the final compiled response that the main agent assembles from the various sub-agent outputs, rather than raw intermediate messages, so the third statement is true. Finally, it is not the sub-agents that decide who should run next. The main agent is the one that chooses which specialist to invoke for a given user request, which means the last statement is false. Question 22. Arrange the following steps to add and use a custom function tool with an agent. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. First step. Define a Python function with type hints and annotated or field descriptions. Second step. Pass the function or list of functions via the tools parameter when creating the chat agent. Third step. Framework registers the function and makes it callable by the AI. Fourth step. Ask the agent a question that naturally requires the tool, so it's called automatically. Now I'm going to explain why this order makes sense when wiring a custom function into an agent. Firstly, you must define the Python function with clear type hints and annotated or field descriptions, so the system understands each parameter and can expose the tools safely to the model. Next, you attach this function to the agent by passing it through the tools parameter at chat agent creation time, which tells the framework that this function should be available as a callable tool. Then, the framework automatically registers the function and links it to the AI model, so the model can choose to invoke it whenever its capability matches the user's request. Finally, you ask the agent a question that logically requires that tool, and because the description and types are already in place, the model decides to call the function, uses its result, and returns a contextually accurate answer as part of the conversation. Question 23. A developer added a function as a tool for an AI agent, but didn't include any descriptions for the inputs or purpose. During testing, the AI fails to use the function correctly. What caused this issue? Select one answer. Option A, the function used type annotations that were too detailed. Option B, the function lacked descriptive information, so the AI couldn't understand how to call it correctly. Option C, the function was defined in Python instead of another language. Option D, the chat agent was initialized without instructions text. The correct answer is option B. The function lacked descriptive information, so the AI couldn't understand how to call it correctly. Now let us go through why this is the cause of the problem. When a function is exposed as a tool, the AI relies on the human-written descriptions of the inputs, outputs, and purpose to decide when it should call that function and how to fill in each parameter. Without those descriptions, the model only sees raw names and types, so it cannot confidently match a user request to the right tool or choose sensible arguments, which leads to incorrect or missing calls. By contrast, defining the function in Python is exactly what the tooling expects, so option C cannot be the issue. Likewise, using detailed type annotations actually helps the system by adding structure and clarity, so option A does not explain the failure. Finally, instructions text for the chat agent guides overall behavior, but tool invocation specifically depends on the metadata attached to the function itself, so option D is not the root cause either. Therefore, the missing descriptive information on the function is what prevented the AI from using the tool correctly. Question 24. What is a primary benefit of providing an OpenAPI 3.0 specification when connecting an agent to an external HTTP API? Select one answer. Option A, automatic conversion of all APIs to event-driven functions. Option B, a low-code canvas for drag-and-drop workflow automation. Option C, direct access to event triggers and bindings for non-HTTP data sources. Option D, standardized, automated integration that supports understanding the API, generating clients, and creating tests. The correct answer is option D, standardized, automated integration that supports understanding the API, generating clients, and creating tests. Now let us unpack why option D is the right choice. Firstly, an OpenAPI 3.0 document is a formal description of an HTTP API, including paths, methods, parameters, and response schemas, so it gives tools and agents a standardized way to understand how the API works. Secondly, because the specification is machine-readable, it can be used to automatically generate client libraries, interactive documentation, and test suites, which is exactly what the answer text describes. By contrast, option A talks about converting APIs into event-driven functions, which is not something OpenAPI does. It only describes APIs. It does not transform them. Option B sounds more like a description of a low-code workflow product, such as a visual logic designer, which is unrelated to the OpenAPI format itself. Option C refers to event triggers and bindings for non-HTTP data sources, which aligns more with Azure Functions bindings than with OpenAPI specifications. Therefore, the key benefit of supplying an OpenAPI 3.0 specification in this context is the standardized, automated integration that helps everyone and everything understand the API, generate clients, and create tests. Question 25. Which two responsibilities are specific to connected, the main agent, not the main agent? Select two answers. Option A, completing a specific action based on a clear prompt. Option B, returning results to the main agent. Option C, selecting which agent is best suited for the task. Option D, interpreting the user's input. The correct answers are option A, completing a specific action based on a clear prompt, and option B, returning results to the main agent. Now let us walk through why these are the connected agent's responsibilities. Connected agents, sometimes called subagents, are designed to handle narrowly defined tasks. So when the main agent sends them a clear prompt, such as calculate this budget or summarize this document, their job is to complete that specific action and nothing more, which matches option A. Once they finish their work, they do not talk directly to the user. Instead, they send their outputs back to the main agent so it can combine, rephrase, or decide the next step, which is exactly what option B describes. By contrast, choosing which agent is best suited for the task is orchestration logic handled by the main agent, not by the connected agents themselves. So option C belongs to the main agent. Similarly, interpreting the user's input and figuring out overall intent happens at the main agent level before any subagent is called. So option D is also not a connected agent responsibility. Question 26. Which decorator is used to mark server functions as MCP tools so they can be discovered by clients? Select one answer. Option A at fastmcp.server, option B at mcp.tool, option C at agent.register, option D at async.function. The correct answer is option B at mcp.tool. Now let us walk through why option B is the right one. Since the @mcp.tool decorator is specifically designed to expose server-side functions as MCP tools so that clients can automatically discover and invoke them through the protocol. When you place this decorator above a function definition, you are essentially registering it as a tool with the MCP server, including its name, parameters, and description, which the client can read from the schema. By contrast, @fastmcp.server is not a valid decorator for individual tools. It relates to server setup rather than marking a function as discoverable. Similarly, @agent.register would belong on the client or agent side for registration logic, not on the server function itself. Finally, @async.function would suggest an asynchronous wrapper style, but async behavior is handled by the language and framework, not by a discovery decorator. So it does not register the function as an MCP tool. Therefore, The decorator that correctly marks server functions as MCP tools is at mcp.tool. Question 27. Which statement correctly describes how control is managed in sequential orchestration? Select one answer. Option A, agents collaborate in real time to decide task order. Option B, the sequence of agents is chosen randomly at runtime. Option C, each agent dynamically decides the next step during workflow execution. Option D, the order of execution is predetermined, and agents do not decide what happens next. The correct answer is option D. The order of execution is predetermined, and agents do not decide what happens next. Now let us unpack why this is true for sequential orchestration. In a sequential pattern, the workflow follows a fixed script, moving from one agent or step to the next in a predefined order, so control sits in the orchestrator's design rather than inside each agent. Consequently, agents simply perform their assigned task when their turn comes, without negotiating the order, making real-time collaboration, randomness, or dynamic next-step decisions inappropriate descriptions. Instead, options A, B, and C all point to more dynamic or group-based orchestration styles, not the strict linear control flow that defines sequential orchestration. Question 28. Fill in the blanks by selecting the correct options from the drop-down menus. Active learning improves a knowledge base by suggesting alternate question phrasings for existing pairs, while defining synonyms ensures that words such as reservation and booking are treated as equivalent terms. Now, let us explain how each part contributes to a stronger knowledge base. Active learning watches how real users phrase their questions and then proposes alternate question phrasings, so the system can recognize many different ways of asking for the same information. At the same time, configuring synonyms tells the system that certain words share similar meaning, so reservation and booking point to the same concept, instead of being treated as separate ideas. Labeling them as equivalent terms means the knowledge base returns the same answer regardless of which word the user chooses, keeping responses consistent and improving accuracy across varied language. Question 29. Fill in the blanks by selecting the correct options from the drop-down menus. Effective custom NER labeling emphasizes consistency, precision, and completeness. In the labeling JSON, the list of entity types appears in assets.entities, while per document spans are recorded under documents, then entities, then labels. Now let us explain why these choices matter for custom NER projects. Consistency means you label the same kind of entity the same way across all documents, which prevents the model from receiving mixed signals during training. Precision means you select exactly the intended text span for an entity, without including extra spaces or surrounding words, so the model learns clean boundaries. Completeness means you label all occurrences of each entity type, instead of skipping some, so the model sees enough examples to learn robust patterns. In the JSON structure, assets.entities is where the project stores the master list of entity type definitions, such as person or location, while documents, then entities, then labels, is where each document's actual offset and length spans are stored, tying specific pieces of text back to those entity types. Question 30. Fill in the blanks by selecting the correct options from the drop-down menus. The Azure AI Translator provides an API for translating text between over 90 supported languages, enabling multilingual communication across global applications. Now let us explain why these choices fit the sentence so well. Azure AI Translator is specifically built for translating text, so that phrase correctly captures its core function, rather than sentiment analysis or security features. In addition, the service supports over 90 supported languages, which highlights its breadth and makes it suitable for global applications, far beyond just a handful of languages. Putting these together, the completed statement accurately describes how the Translator API enables multilingual communication across many different regions and language pairs. Question 31. For each Azure AI speech service concept, drag it to the appropriate description in the correct match column. Each item may be used once, more than once, or not at all. Defines the structure and technical parameters of generated speech audio. Correct match, audio format. Identifies the language and persona used for synthesized speech. Correct match, voice. Specifies characteristics such as sample rate and bit depth. Correct match, audio format. Uses a locale code and person's name, for example, ENGB George. Correct match, voice. Now let us go through why each description maps to its concept so clearly. Audio format is all about how the sound file is structured, so it naturally covers the overall technical parameters of the generated speech, including things like encoding, sample rate, and bit depth, which is why it matches both the first and third statements. In contrast, voice refers to the specific synthesized speaker, so it defines the language and persona of the speech, such as a male or female voice or a particular style, making it the right match for the second statement. Each voice in Azure AI Speech is identified by a locale code plus a name, like OnGB George, which directly supports the fourth statement and confirms that voice is also the correct match there. Speech configuration and speech synthesis stream are related objects, but they manage settings or represent the audio data itself, rather than defining the core audio format or the identity of the voice, so they remain unused in this question. Question 32. For each EdSSML capability, drag it to the description in the correct match column. Each item may be used once, more than once, or not at all. Define how a string should be read as a date, time, or telephone number. Correct match. Say as rules. Insert a brief pause between words or sentences. Correct match. Break, pause. Provide explicit pronunciation using phonetic symbols. Correct match. Phonemes. Modify pitch, timbre, or speaking rate of the voice. Correct match. Prosody adjustment. Apply an expressive speaking style such as cheerful to a neural voice. Correct match. Expressive style for neural voice. Mix in a pre-recorded clip or background audio. Correct match. Insert recorded audio. Now let us walk through why each capability matches its description so clearly. Say as rules are used when you want structured data like dates, times, or phone numbers to be spoken in a natural way instead of literally reading every character, so they define how a string should be read. Break, pause inserts a configurable bit of silence, which creates natural gaps between words or sentences and makes the speech easier to follow. Phonemes let you spell out exactly how a word should sound using phonetic symbols, which is perfect for product names or acronyms that are pronounced differently from their spelling. Prosody adjustment controls pitch, timbre, and speaking rate, so it is the tool you use to make the voice sound higher, slower, faster, or richer overall. Expressive style for neural voice applies emotional styles such as cheerful or excited, adding personality and making neural voices feel more lifelike. Finally, insert recorded audio allows you to mix in pre-recorded clips or background sounds so they play inside the synthesized output, which is useful for jingles, alerts, or ambient audio behind the narration. Question 33. A data analytics company wants to process millions of product reviews to discover emerging customer concerns. They decide to use an AI service capable of extracting meaning and relationships from unstructured text using statistical and semantic models. Which Azure capability best meets this need? Select one answer. Option A, Azure AI Language. Option B, Azure AI Speech. Option C, Azure AI Vision. Option D, Azure Machine Learning AutoML. The correct answer is option A, Azure AI Language. Let us unpack why this is the right choice. Azure AI Language is designed specifically to analyze large volumes of unstructured text using statistical and semantic language models to detect topics, sentiment, key phrases, and relationships between concepts, which is exactly what you need for millions of product reviews. Azure AI Speech on the other hand, focuses on converting spoken audio to text or back to speech, not on deep text analytics. Azure AI Vision works with images and video rather than written reviews, so it does not fit the scenario. Azure Machine Learning AutoML helps automate model training, but it does not by itself provide ready-made capabilities for extracting meaning and relationships from text at scale. Question 34. For each statement below, indicate whether it is true or false. Pre-built entity components can detect numbers, emails, and URLs. Answer: true. You must provide training examples for each pre-built entity type. Answer: false. A single entity can include multiple pre-built components. Answer: true. Using pre-built components typically increases the time needed to build a model. Answer: false. Now let us go through the reasoning. So these points are easy to remember. First, pre-built entity components are designed to recognize common patterns like numbers, email addresses, and URLs right out of the box. So that first statement is true because they automatically detect those without extra work. Secondly, you do not need to label training data for these pre-built types. They already come trained, which is why the statement about having to provide training examples for each pre-built entity type is false. Third, a single entity definition can combine several pre-built components. For example, capturing both a number and a date inside one entity. So it is true that a single entity can include multiple pre-built components. Finally, using these ready-made components actually speeds up development because you skip custom training for common patterns, so the idea that they increase the time needed to build a model is false. Question 35. A developer submits a classification request through the REST API and receives a response with an operation location header. What should they do next? Select one answer. A. Use the URL in the operation location header to retrieve classification results. B. Immediately resend the same classification request. C. Deploy the model again before viewing results. D. Modify the JSON body and resubmit with a new project name. The correct answer is A. Use the URL in the operation location header to retrieve classification results. Now I'm going to explain how we arrived at the correct choice. First, the presence of an operation location header indicates that the request is being processed asynchronously. Consequently, instead of resending the same request or redeploying the model, the proper next step is to pull the URL contained in that header. This URL points to the operations status endpoint, which will eventually provide the completed classification results. Moreover, repeatedly resending the request would waste resources and produce duplicate tasks. Similarly, redeploying the model is unnecessary because deployment is only required when changes are made to the model itself. Finally, modifying the JSON and resubmitting creates a new operation entirely, which does not help retrieve the results of the original request. In practice, asynchronous operations are common in cloud APIs because they allow long-running tasks such as image or text classification to complete without blocking the client. A real-world example would be submitting a large document for an analysis and checking back periodically using the operation location link until processing has finished. That is why option A is the correct and most efficient response. Question 36. Arrange the following steps involved in building a custom NER model in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. First, define entities. Second, tag data. Third, train model. Fourth, view model. Fifth, improve model. Sixth, deploy model. Seventh, extract entities. Now let us walk through why this order makes sense when building a custom NER model. You begin by defining entities, so the system knows which types of information to look for, such as product names, order numbers, or locations. Next, you tag data by labeling these entities in sample texts, creating the training set the model will learn from. After that, you train the model so it can recognize those patterns on its own. Then you view the model's results to evaluate accuracy on test data. If performance is not yet where you want it, you improve the model by refining labels or adding more examples. Once the model performs well, you deploy the model so applications can call it in production. Finally, you use that deployed model to extract entities from new unseen text, such as incoming customer emails or support tickets. Question 37. For each statement below, indicate whether it is true or false. Traditional AI chat systems relied mainly on text input for communication. Answer: true. Multimodal models were the first form of AI capable of handling any type of input. Answer: false. Generative AI focuses solely on numerical data processing. Answer: false. Azure AI Foundry documentation provides additional resources for exploring available AI models. Answer: true. Now let us walk through why each of these answers makes sense. Traditional AI chat systems did indeed rely mostly on text, since earlier chatbots were built around typed messages before support for images, audio, or video became common. So the first statement is true. The second statement is false because AI systems existed long before multimodal models, but they were usually limited to a single input type like text or audio. Multimodal models are a more recent step that combines several input types rather than being the very first AI capable of handling input at all. The third statement is also false because generative AI certainly uses numbers under the hood, but its purpose is to create human-like outputs such as text, images, or audio, not to focus only on raw numerical calculations. Finally, the fourth statement is true, since Azure AI Foundry documentation does provide links, guides, and references that help users explore the different AI models available and understand when to use each one. Question 38. A travel company wants to extract and categorize information such as city names, dates, and people mentioned in customer feedback messages. Which Azure AI language feature should they use? Select one answer. Option A, entity recognition. Option B, sentiment analysis. Option C, key phrase extraction. Option D, language detection. The correct answer is option A, entity recognition. Now, I am going to explain why entity recognition is the best fit for this scenario. Entity recognition is designed to scan text and automatically find structured items like cities, dates, and people's names, then label them with categories such as location, date, or person, which is exactly what the travel company needs to organize feedback. By contrast, sentiment analysis focuses on whether the review is positive or negative, so it measures tone rather than pulling out those specific details. Similarly, key phrase extraction highlights main topics or themes in a sentence, like flight delays or hotel service, but it does not label individual cities or people as specific entity types. Finally, language detection simply tells you which language the message is written in, such as English or Spanish, and does not extract any of the concrete facts buried in the feedback. Therefore, entity recognition is the feature that allows the company to reliably extract and categorize city names, dates, and people from their customer messages. Question 39. What is the purpose of active learning in a question answering project? Select one answer. Option A, to translate answers into multiple languages. Option B, to suggest alternate phrasings for existing questions. Option C, to assign access permissions to knowledge bases. Option D, to host multiple knowledge bases in the same resource. The correct answer is option B, to suggest alternate phrasings for existing questions. Now let us talk through why this is the right choice. Active learning watches how users actually phrase their questions and then suggests new alternate phrasings for the existing Q&A pairs, so the system can recognize many different ways of asking for the same answer and improve its match rate over time. It does not perform translation, so option A is outside its scope because language translation is handled by dedicated translation services. Option C is about security and access control, which is managed through Azure roles rather than through the learning mechanism of the question answering model. Option D is about resource organization, letting you host multiple knowledge bases, but that has nothing to do with improving how the model understands user queries. Therefore, the true purpose of active learning here is to suggest alternate phrasings for existing questions, so the project handles varied user input more accurately over time. Question 40. To use the Azure AI Translator APIs from your code, what two pieces of information are required from the resource you provisioned? Select two answers. Option A, the subscription key. Option B, the resource location. Option C, the tenant ID. Option D, the resource tag. The correct answers are Option A, the subscription key, and Option B, the resource location. Now let us walk through why these two are required so the API calls will actually work. Firstly, the subscription key is essential because it is what authenticates your requests to the translator service, proving that your code is allowed to use that Azure resource and enabling the service to track billing and usage. Secondly, the resource location tells your code which regional endpoint to call, such as a specific Azure region where the translator instance was created, and using the wrong region would cause requests to fail. However, the tenant ID is mainly used for directory or identity scenarios like Entra ID configuration, not for basic key-based translator API calls. Finally, the resource tag is just metadata that helps you organize and manage resources in the portal, so it is never sent in the API request, which is why only the subscription key and the resource location are required from your code. Question 41. A localization developer is building an app that must display translated text but also needs to identify which characters in the source course correspond to which characters in the translation. Which parameter should they enable? Select one answer. Option A, include sentence length. Option B, include alignment. Option C, profanity action. Option D, profanity marker. The correct answer is option B, include alignment. Now let us explain why this parameter is the right choice for the scenario. The requirement is to know exactly which characters in the source line up with which characters in the translated text, and include alignment returns an alignment object that maps source character positions to target character positions, giving the developer the precise mapping they need. By contrast, include sentence length only reports the length of sentences and does not tell you how individual characters or words correspond between source and target. The profanity action parameter controls how potentially offensive terms are handled, such as masking or deleting them, which is unrelated to alignment. Similarly, profanity marker changes how those flagged profanities are displayed, for example, by adding symbols. But again, it does not provide any positional mapping between the original and translated strings. Therefore, enabling include alignment is what allows the app to link source characters to their translated counterparts accurately. Question 42. Generative AI enables the creation of what type of applications that can understand and reason over input? Select one answer. Option A, chat-based intelligent applications. Option B, static data visualization dashboards. Option C, automated database indexing tools. Option D, hardware control interfaces. The correct answer is option A, chat-based intelligent applications. Now let us unpack why this option is the best fit. Generative AI is designed to support natural, conversational interactions, where the system can interpret user input, reason over it, and then produce relevant, context-aware responses, which is exactly what chat-based intelligent applications do. These applications can hold multi-turn conversations, follow instructions, and adapt their answers as new information appears, all of which rely on generative models rather than simple rules. In contrast, Static data visualization dashboards mainly display charts and graphs from existing data and do not involve generative reasoning over free-form input. Automated database indexing tools usually focus on back-end optimization tasks like reorganizing indexes, not on understanding natural language queries. Hardware control interfaces typically depend on embedded logic and fixed commands rather than generative AI models that produce rich, conversational responses. Therefore, the type of applications unlocked by generative AI for understanding and reasoning over input are chat-based intelligent applications. Question 43. Which component must be included in every Azure AI Language REST API call to specify the correct service release being used? Select one answer. Option A, API version parameter. Option B, subscription region. Option C, deployment slot name. Option D, model language tag. The correct answer is option A, API version parameter. Let us now unpack why option A is required in every call. Firstly, each Azure AI Language REST endpoint expects a query string, such as $API -version equals a specific date. And this API version parameter tells the service exactly which release of the API your request targets, so without it, the call can fail or hit an unexpected default. Secondly, the subscription region is important for choosing the correct endpoint URL. But once you are calling that regional endpoint, it does not by itself specify which version of the service you want, so option B is not the mandatory version marker. Furthermore, the deployment slot name applies to scenarios like web apps where you separate staging and production, and it is not part of standard Azure AI Language REST parameters, which rules out option C. Finally, the model language tag is usually provided inside the request body or configuration to indicate which language model should operate on the text. And while that can be necessary for certain operations, it is not the universal parameter that identifies the service release. Therefore, the one component that must always be included to specify the correct service version is the API version parameter. Question 44. When making a translation call using a custom model, which three components must be included in the request? Select three answers. Option A, the API version parameter. Option B, the category parameter containing the model's category ID. Option C, the alignment parameter for word mapping. Option D, the two parameters specifying the target language. The correct answers are option A, the API version parameter. Option B, the category parameter containing the model's category ID, and option D, the two parameters specifying the target language. Now let us walk through why these three are required for a custom model call. First, the API version parameter is mandatory in every translator request because it tells the service which release of the API you want to use, so without it the request may fail or hit the wrong version. Next, when you are using a custom translation model, the category parameter carrying the model's category ID is what directs the service to your trained model instead of the default generic model, so it has to be present in the query. Then, the two parameters specifying the target language indicates which language you want to translate into. For example, to equals FR for French, and a translation call cannot work without a target language. By contrast, the alignment parameter is optional and only used when you need word or character level mapping information between source and target, so it is helpful for analysis or highlighting, but not required just to perform the translation. Question 45. You're rewriting a working speech prototype from Python to C#? The architecture, meaning the resource, key, region, and purpose, stays the same. Which statement best reflects what you should expect during the rewrite? Select one answer. Option A, you can copy the Python method names into C# unchanged because all speech SDKs use identical names and signatures. Option B, syntax and parameters will differ by language, but you will still create an object that configures the connection to the speech resource. Option C, No configuration object is needed in C# because the key and region are inferred automatically. Option D. The region value used in Python cannot be reused in C#. The correct answer is option B. Syntax and parameters will differ by language, but you will still create an object that configures the connection to the speech resource. Now let's talk through why this is the right expectation when you move from Python to C#. Even though you are targeting the same speech resource with the same key and region, each language SDK has its own naming style, method signatures, and object patterns, so you cannot just copy and paste the Python methods into C# and expect them to compile. However, the overall concept is consistent across SDKs. You still construct a configuration-style object, such as a speech config, that takes your key and region and wires the client up to the same speech resource. Options C and D both contradict this shared architecture, because C# does not magically infer your key and region, and the region string like istas is reusable regardless of language. So in practice, you keep the same resource details, but you rewrite the code using C# syntax and APIs while still creating a configuration object to connect to the speech resource. Question 46. Which statement best distinguishes a dedicated Azure AI speech resource from multi-service resources, such as Azure AI Services or Azure AI Foundry? Select one answer. Option A. A dedicated speech resource supports only speech-related APIs, while multi-service resources can include speech along with other Azure AI capabilities. Option B. Multi-service resources are limited to speech recognition and exclude text-to-speech features. Option C. Dedicated speech resources are automatically linked to Azure AI Foundry for cross-service management. Option D. Dedicated speech resources and multi-service resources are identical in scope and functionality. The correct answer is option A. A dedicated speech resource supports only speech-related APIs, while multi-service resources can include speech along with other Azure AI capabilities. Here is why this distinction matters. A dedicated speech resource is scoped just to speech, so it exposes only speech-related APIs, such as speech-to-text, text-to-speech, and related features, which is ideal when your solution is focused solely on speech. In contrast, a multi-service resource can host speech alongside other Azure AI capabilities like vision or language, giving you a single resource that covers multiple services under one billing and management umbrella. Option B is incorrect because multi-service resources can still use the full speech feature set, including both recognition and synthesis. Option C is wrong since there is no automatic linkage between a dedicated speech resource and Azure AI Foundry. They are configured separately. Option D is also incorrect because the whole point is that they differ in scope, with dedicated resources focused on speech only and multi-service resources spanning several Azure AI services. Question 47. Fill in the blanks by selecting the correct options from the drop-down menus. To request a classification, a client authenticates with a prediction resource key against a prediction endpoint, calls the method with the project ID and published model name, and submits the image bytes or stream to receive tag probabilities. Now let's break down why each part is needed in this workflow. First, the prediction resource key is used to authenticate the client, proving it has permission to call the custom vision prediction service, while the prediction endpoint tells the SDK which URN region to send the request to. Next, the project ID and the published model name identify exactly which trained classification model inside that project should handle the image, since you might have multiple iterations or model types available. Finally, the client sends the actual image bytes or stream as the input for the model, and in response, the service returns tag probabilities, which are the confidence scores for each label the model has learned, allowing the application to decide which tags best describe the image. Question 48. Arrange the steps to enable a custom people model. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. First step, obtain limited access approval for people recognition. Second step, add face images of the individuals to recognize. Third step, train the people model. Fourth step, run analyses so those individuals can be recognized across all videos. Now let's walk through why the steps follow this sequence. You begin by obtaining limited access approval for people recognition because this capability is gated, and you cannot use it until Microsoft approves your request. Once you have access, you upload or add face images of the specific individuals you want the system to recognize, so the service has examples to learn from. After those faces are in place, you train the people model so it can build representations of each person's identity from those images. Finally, you run analyses on your video library, and the trained model automatically spots and labels those individuals across all videos, enabling search and tracking based on who appears where. Question 49. For each REST endpoint, drag the correct function into the correct match column. Each item may be used once, more than once, or not at all. /auth, locations, accounts, account ID, access token. Correct answer. Access token. Accounts, account ID, videos. Correct answer. Video metadata. Accounts, account ID, customization, custom logos, logo ID. Correct answer. Custom logo retrieval. I am now going to explain how each answer fits its correct match. To begin with, the auth access token endpoint exists solely to issue an authentication token. This token is required before any additional REST calls can be made, much like signing in before accessing protected areas of an application. Because of this, access token is the only correct mapping. Next, the video's endpoint focuses on managing video information. It exposes details such as metadata and associated properties, so video metadata is the correct match. For instance, a system might call this endpoint to fetch the duration or thumbnail information before displaying video previews. Finally, the custom logos endpoint retrieves branded visual assets linked to the account. Since these are graphical resources used for customization, the appropriate function is custom logo retrieval. In real-world scenarios, this allows applications to pull logos for overlays, watermarks, or UI branding. Altogether, each endpoint aligns precisely with its operational purpose, ensuring clean separation between authentication, media metadata retrieval, and branding resource access. Question 50. For each statement below, indicate whether it is true or false. Statement 1. Language models in Azure AI Foundry can create various content types, including text and images. Answer. True, true. Statement 2. DALL-E3 and GPT-Image1 are examples of image generation models available in Azure AI Foundry. Answer. True. Statement 3. Image generation models reuse pictures from public databases. Answer. False. Statement 4. Describing an image prompt in natural language is the primary way to direct the model's output. Answer. True. Now let's walk through the reasoning, so each one sticks. For the first statement, Azure AI Foundry does let you work with models that generate multiple content types, such as text, images, and sometimes even other modalities, all driven from natural language prompts. So that is true. The second statement is also true because DALL-E3 and GPT-Image1 are both supported image generation models in Azure AI Foundry, used specifically for creating images from prompts. The third statement is false because these models do not simply reuse or copy pictures from public databases. Instead, they synthesize entirely new images based on patterns learned during training. Finally, the fourth statement is true, since the main way you control what these image models produce is by writing a natural language prompt that describes the desired scene, style, or objects, which guides the visual output they generate. Question 51. A multi-part user message for a vision chat typically includes which two content item types? Select two answers. Option A, text. Option B, binary blob. Option C, image URL. Option D, schema. Option E, query plan. The correct answers are option A, text, and option C, image URL. Now let's walk through why these are the two that appear in a Vision Chat message. The text content item carries the natural language instruction or question, such as, describe what is happening in this image, or what objects do you see here? And that is how the user tells the model what to do. The image URL content item then supplies the actual image, either as a standard URL or as a base64 data URL, giving the model visual input to analyze alongside the text. In contrast, binary blob refers to raw bytes and is not the named content type in the chat schema, while schema and query plan are structural or planning concepts, not user message content items, so they are not used in the standard multi-part Vision Chat payload. Question 52. How does face comparison differ from verification in Azure Face API? Select one answer. Option A, comparison requires persisted faces. Verification does not. Option B, verification works only across videos. Comparison works only on images. Option C, comparison measures visual similarity. Verification checks if two faces belong to the same person. Option D, comparison and verification are identical features under different names. The correct answer is option C. Comparison measures visual similarity. Verification checks if two faces belong to the same person. Here is the key distinction. Face comparison looks at two faces and returns a similarity score that tells you how visually alike they are, essentially ranking resemblance without making a firm identity claim. Verification, on the other hand, is an identity check. It answers the question, do these two faces belong to the same person, giving you a yes or no style confidence about identity match. Comparison does not require persisted faces and works on still images just like verification. And they are not identical features, because one is for similarity scoring, while the other is for confirming identity. Question 53. Your reviewers must edit insights for a specific video inside an internal web page, but you must avoid granting full portal access to the account. What should you use first? Select one answer. Option A, call the REST API only and build a custom editor from scratch. Option B, use the built-in widgets to embed the player and insights for that single video. Option C, share your portal credentials with reviewers temporarily. Option D, deploy a CDN and host a copy of the video with public access. The correct answer is option B. Use the built-in widgets to embed the player and insights for that single video. Here is why this is the best approach in this scenario. The built-in widgets from Video Indexer let you embed a scoped player and insights editor directly into your internal site, targeting just that specific video, so reviewers can play, analyze, and edit insights without ever receiving full portal access to your account. This aligns with least privileged security practices because you expose only what they need for that one video. Option A, using only the REST API, is technically possible, but requires significantly more engineering effort to build a full editor experience, while the question emphasizes what you should use first for a quick scoped solution. Option C, sharing your portal credentials, is unsafe because it grants broad tire account and violates security best practices. Option D, deploying a CDN and hosting a public copy, might let reviewers watch the video, but would not expose the Video Indexer insights or editing tools at all. Therefore, starting with the built-in widgets is the quickest and safest way to let reviewers edit insights for a single video inside your internal page. Question 54. Which of the following options can you configure when generating images in the Azure AI Foundry Images Playground? Select three answers. Option A, image resolution. Option B, image style. Option C, image quality. Option D, prompt text language. Option E, image file compression type. The correct answers are Option A, image resolution, Option B, image style, and Option C, image quality. Here is why each of these is configurable in the images playground. Image resolution lets you choose the output size of the generated picture, for example 1024 by 1024, so you can control how large and detailed the image is. Image style allows you to switch between different visual looks, such as more vivid or more natural rendering, which changes the artistic feel of the result. Image quality lets you select between standard and HD rendering, affecting how sharp and refined the final image appears. Prompt text language, Option D, can be any language you type into the prompt box, but there is no explicit setting to toggle it as a configuration option, so it is not counted here. Image file compression type, Option E, is not exposed as a separate configuration in the playground, so you cannot adjust it directly when generating images. N. Question 55. For each statement, indicate whether it's true or false. Statement 1. You can access Azure Document Intelligence through the Azure portal or Azure CLI. Correct answer. Statement 2. A single service resource is required for Microsoft Entra authentication. Correct answer. True. Statement 3. The free tier F0 allows up to 500 megabytes per file. Correct answer. False. Statement 4. Image dimensions must fall between 50 by 50 pixels and 10,000 by 10,000 pixels. Correct answer. True. Now let's go through the explanation together. First, Azure Document Intelligence is just an Azure resource, so of course you can create and manage it either in the Azure portal or by using the Azure CLI. Next, Microsoft Entra Authentication expects a dedicated single service resource because multi-service resources mix several APIs and would complicate identity and role assignments. Furthermore, the free F0 tier is intentionally limited. It actually supports files only up to about 4 megabytes, while the paid S0 tier goes up to 500 megabytes, so that statement had to be false. Finally, the pixel range from 50 by 50 up to 10,000 by 10,000 defines what the service can reliably process. Images smaller or larger than this range are rejected, which is why that last statement is true. Question 56. Fill in the blanks by selecting the correct options from the drop-down menus. To train a custom model, store sample forms in an Azure Blob container and include JSON files. The container must have a shared access signature URL to grant access to Azure Document Intelligence. Now I'm going to explain why these are the correct choices. First, Azure Document Intelligence needs all your training documents to live together in a storage location that it can read, and in Azure, that standard place is an Azure Blob container. It is like putting all your scanned forms into one clearly labeled folder in the cloud so the service knows where to look. Next, you include JSON files alongside those forms because they describe the layout, the field labels, and where each piece of information sits on the page. In other words, they are the answer key that teaches the model what each region of the document means. Finally, the service still cannot open that container unless you grant it permission, so you generate a shared access signature URL, which is a secure, time-bound link that says you can read only this container for a limited period. In a real project, you would create the container, upload your forms and JSON definitions, then share that SAS URL with Document Intelligence so it can train your custom model automatically from those samples. Question 57. Arrange the following steps to describe how enriched data is persisted through a knowledge store. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Step 1. Define a knowledge store as part of the skill set. Step 2. Run the indexer to process and enrich the data. Step 3. Generate projections such as JSON, tables, or images. Step 4. Persist the projections in the knowledge store. Now I'm going to explain why this is the correct order. First, you define a knowledge store as part of the skill set, because you must tell Azure AI Search where enriched data will be saved and in what shapes it should appear, such as blobs, tables, or documents. Next, you run the indexer to process and enrich the data. The indexer is the worker that reads your original content, applies skills like OCR or entity extraction, and produces enriched information. Afterward, those enrichment results need a usable structure, so the system generates projections, for example, a JSON document, a relational table row, or an image file representing the transformed data. Finally, these projections are persisted in the knowledge store, typically in Azure Storage or Cosmos DB, so that downstream applications can query, analyze, or reuse the enriched content later on, just like reading from a well-organized data warehouse. Question 58. A polling company processes 3 categories of documents: unique survey forms they design themselves, vendor invoices and store receipts for expenses, and US W-2 forms received from temporary staff. The team wants reliable extraction with minimal development effort. Select 2 answers. Option A. Use a pre-built model for invoices and receipts to extract totals and line items. Option B. Train a custom model for the unique survey forms to improve precision on their structure. Option C. Use the ID document model for the W-2 forms because both contain personal details. Option D. Use the US tax model for W-2 forms to extract tax-specific fields. The correct answers are: A. Use a pre-built model for invoices and receipts to extract totals and line items, and D. Use the US tax model for W-2 forms to extract tax-specific fields. Now let us explain why these are best. First, invoices and receipts are classic scenarios already covered by pre-built invoice and receipt models in Azure AI Document Intelligence, so you get totals and line items out of the box with almost no configuration, which perfectly matches the requirement for minimal development effort. Next, W-2 forms are tax documents. Therefore, the US tax model already understands fields such as wages and withholding, giving accurate extraction without custom training. Conversely, training a custom model for every unique survey form would require labeled data and extra time, which conflicts with the minimal effort requirement. Finally, the ID document model focuses on IDs such as passports and driver licenses, so it would miss many tax-specific fields on W-2 forms, making option C unsuitable. Question 59. For each layout model capability in the option column, drag the document structure challenge from the item list to the correct match column. Each item may be used once, more than once, or not at all. Robust extraction despite skewed or angled scans, pages scanned at an odd angle. Support for cells spanning multiple rows or columns, tables with merged cells, extraction tolerant of incomplete table structures, tables missing some columns or rows, cell output includes row or column indexes, need row or column index for each cell. Now I will explain how we arrive at these answers. To begin with, robust extraction despite skewed or angled scans pairs naturally with pages scanned at an odd angle. Because the layout model is specifically designed to handle documents that are rotated or scanned imperfectly, this makes it possible to recover structure even when the geometry isn't straight. Next, support for cells spanning multiple rows or columns aligns with tables with merged cells, since merged cells often extend across multiple rows or columns, and the layout model must correctly interpret those spans to maintain table integrity. Furthermore, extraction tolerant of incomplete table structures connects to tables missing some columns or rows because the model is built to cope with partial or damaged tables and still reconstruct whatever structure is available. Finally, cell output includes row or column indexes must match. Need row or column index for each cell, since the return data includes positional information, making it possible to understand exactly where each extracted cell belongs within the table layout. In real applications, scenarios like scanned receipts, Invoices with irregular grids or forms with missing fields often require these capabilities, and Azure's layout model is designed precisely to manage those inconsistencies while preserving analyzable structure. This completes the explanation. Here is your script following every instruction, tailored to question 60 and formatted for natural TTS pacing with smooth transitions and no bullets or dashes. Question 60. Which are valid ways to provision the prerequisite for using the Content Understanding REST API? Select two answers. A. Create only a key vault and skip the Azure AI Services resource. B. Create an Azure AI Services resource in the Azure portal. C. Create an Azure AI Foundry Hub, which includes an Azure AI Services resource. D. Enable public internet routing and query string auth. The correct answers are B. Create an Azure AI Services resource in the Azure portal, and C. Create an Azure AI Foundry Hub, which includes an Azure AI Services resource. Now let's walk through the explanation. To begin with, using the REST API for content understanding requires an Azure AI Services resource. Therefore, option B is valid because provisioning this resource directly in the Azure portal satisfies the prerequisite without any additional setup. This is the most straightforward and commonly used method. Additionally, option C is also valid. An Azure AI Foundry Hub automatically provisions an Azure AI Services resource as part of its setup, meaning developers get the required resource bundled within the hub. This is especially useful when managing multiple AI workloads under a unified workspace. However, creating only a key vault as in option A does not work, because a key vault cannot substitute for the required Azure AI Services resource. It can store secrets, but cannot host or manage content understanding capabilities. Finally, option D is incorrect. Enabling public internet routing and query string authentication is not a provisioning mechanism. Nor is it supported for authentication, therefore it does not fulfill any prerequisite for using the REST API. And that completes the explanation.